Welcome to Cosplay Engineering. I'm ACraftyHobbit, and this month we're talking about adding single LEDs to your cosplay and programming them for the desired effect. Single LEDs are great when you have a single focus point or a small area you want to light. This episode, I will be talking about colored LEDs. I will teach you how to wire them up, program them to get the desired effect, and then put them into actual props. Let's get started. The electronics I'm demoing can be put inside any type of prop. To demonstrate this, I designed and 3D printed two different types of props. The medallion from the Netflix Wicher series and the potions bottle from Final Fantasy 15. The most important part is to make sure you allocate room in the props for the electronics to live and make sure it's easy to get to them if you need to adjust the code or change out the battery. As you can see, I built my props so they easily snap together and have room enough for the electronics. Sometimes this does mean building a prop a bit bigger than it actually is supposed to be in order to make everything fit. In order to figure out how much room was needed, I first wired up the electronic elements. The first place I start when working with electronics for my cosplay is with a breadboard and my Arduino Uno microcontroller. This allows me to easily make sure everything is wired up correctly before moving on to soldering. Soldering mistakes can be a bit trickier to fix. A single LED can be hooked up to a microcontroller on its own and the code will run continuously as long as there is power. However, I like to be able to control my lights with push buttons. For a button to work, it needs power to it, a 10K resistor to ground, and a connection to a pin on the microcontroller. I'm using pin number 2 for this. Next, on to wiring up the LED. LEDs have a positive and negative leg coming out of them. The longer leg is positive and goes to a pin on the microcontroller. I'm using pin number 9. The shorter leg is negative and will need a 220 resistor running from it to ground. Here's what it looks like all wired up. Now it's time to hook up the microcontroller to the computer and start coding to get the desired effects. I use the Arduino IDE for programming my electronics. However, before I start writing any code, I like to check that my wiring is correct with some of their default code. That way, I'm not playing the guessing game of, is it my code or is it the wiring? Under the File menu, there is the Examples menu, which has a sketch called Button. At the topmost part of the actual code, there are two constant variables. These need to match the pin number of the button and LED wired to the microcontroller. Their code is defaulted to pin number 13, so I had to change it to pin number 9 to match my wiring. These numbers do not change. Next, another variable, button state, which can be read to see if the button is pushed or not. Next, you'll see the setup function, which initializes the connection between the microcontroller and the button and LED. Finally, the loop, the most important part. This is where the magic happens. The first thing that happens is it reads the state of the button and records it. With that information, it does one of two things. If the button is pressed or high, it turns the LED on. If the button is not pressed, which means the state is low, the LED should be off. This basic code is great for props where you want to press a trigger and have it light up. Now that I have the basic light on code, let's make it blink, or more specifically, let's make it turn on and off on a regular schedule while the button is pressed. Keeping most of the code from the original sketch, I adjust it to blink when the button is held. Just like before, you see the constant variables that match the pins to the LED and the button. I still have the button state variable. However, I've added two additional variables. LED state to track if the LED is on or off, and button counter, which tracks the number of times the loop has been run. Just like before, the setup function initializes the connection between the microcontroller, the button, and the LED. Finally, into the loop. This is where things get changed. It reads the button just like before. However, if the button is pressed and the state is high, increase the button counter. If the counter is less than 3,000, Compare the LED state. If high or on, turn it off or low, and vice versa. This causes the LED to blink. To change the speed of the blink, increase or decrease the 3000. If the button is low or not being pressed, do nothing. Another effect that can be done to the light is fade, which means gradually increasing and decreasing the brightness of the light over time. We are able to control the brightness by increasing or decreasing the voltage sent through to the LED. Here are the same variables from the original sketch, but now I've added brightness, which controls the brightness, and the fade amount, which is how fast I want it to fade. Here's the setup function, just like before. This time through the loop, however, when the button is pressed, we are tracking the current brightness of the light and increasing or decreasing that brightness. We are then writing that current brightness using analog write, which Arduino uses to define how frequently it switches between on and off. In order for this effect to work, you need to make sure the LED pin can do analog write, which is why I've been using pin number 9 for this. All these examples currently require that you hold the button in order for something to happen, but that doesn't work for every prop. So the last bit of code I want to go over is a basic on-off, which means I just have to press the button once in order for something to happen. Just like in the previous sketches, there's the constant variables that match the pin to the LED and the button. There's also still LED state and button state. However, now I've added 4 additional variables. Previous state, which tracks if the button has been pressed before or not. Mode, which is a counter that allows me to change between different modes. Finally, time and debounce, which are there because there is noise that happens within the loop and it's hard sometimes to read the button, so we track it with time. There's a lot more technical details about debouncing. If you're curious, I would Google it. The thing that you need to know is this needs to be there in order for it to properly turn on and off by the button. Just like before, there is the setup function that initializes that connection between the LEDs, the button, and the microcontroller. Now into the loop. Just like everything else, it reads the button. This time, however, it compares the different states of the button to make sure, and time to make sure that it was actually pressed and it's not noise. If it was pressed, increase the counter of mode, and if that counter is greater than 1, return it to 0. It then looks at mode. If the mode is 0, the LED should be set to off. If the mode is 1, the LED should be turned on. Finally, record the button press. The blink or fade code in the previous examples can be interchanged with the code in mode 1. The number of modes can also be increased, and it can be made to switch between the 3 different types of effects at the push of a button. All my code for these effects can be found in a link in the description below. Now that I've figured out my wiring code and have the props, the last part is to take it from the breadboard and actually solder everything together. I tend to work in small sections and then put them all together in the end. I start with my button, attaching 2 wires, then I divide one of those wires in 2. The 10K resistor is attached to one of those halves. I connect another wire to the resistor, which will eventually run to the ground pin on the microcontroller. Setting the button aside, I move on to my LED. I attach a wire to each leg of the LED. I then attach a 220 ohm resistor to the negative leg, which is the shorter leg on the LED. Setting that aside, I move on to my microcontroller. For this project, I'm using an Adafruit Trinket M0 for my microcontroller. The button, LED, and battery all need ground. I wasn't able to fit 3 wires into the pin hole, but I can fit 2, so one of them is just going to get divided, so I can have my 3rd line. Next, I attach a wire into pin 0, a wire into pin 2, and a wire into 3 volt. The 3 volt is going to power my button. I next connect my button wires to the wires on the microcontroller. I do the same thing with my LED wires, connecting them back to the microcontroller. I plug in a mobile battery to the USB port to make sure everything was soldered correctly and it is working the way I think it will. Adafruit has a li-poly backpack that makes it easy to power their Trinket microcontrollers. It also can be used to charge lithium batteries when the microcontroller is plugged into the port. That is how I'm powering my props for this project. Here's the final diagram of everything connected together. Electronics can be frustrating at times because any number of things could be going wrong. A couple things to check when your electronics aren't working is, does the code pin numbers match the pins actually wired to the microcontroller? Different microcontrollers require different libraries. Not all of them come standard with Arduino's IDE. Make sure that you have the proper libraries downloaded for your microcontroller. Lastly, check your soldering. Are there connections being made between pins that there shouldn't be and it's causing short? While electronics can be frustrating at times, the results are super fun. Thanks for watching this episode of Cosplay Engineering. Next episode, I will be continuing the month's theme of single LEDs, except this time I will be going over RGB or programmable LEDs, which allows you to then change the color of the light. I, of course, will have 2 new props for those LEDs. To see what I'm up to between episodes, make sure to follow me on my social media and subscribe to this channel and hit that bell. Thanks for watching. Bye!